Today, we're going to talk about a small, but honestly, a really mighty piece of technology. It's something that makes the invisible visible and keeps thousands of people safe every single day. We're talking about the film badge dosimeter.
So let's start with a really basic question. Radiation. It's all around us, but you can't see it, you can't smell it, you can't hear it. It's totally invisible. So how in the world do you measure a danger that you can't even perceive? And that right there, that's the whole challenge, isn't it? For anyone who works near radioactive materials, dealing with this invisible danger isn't just, a good idea. It is an absolute necessity for their safety. And this is the solution that scientists came up with. And it's actually elegantly simple. It's called a film badge dosimeter. Now, it doesn't block radiation or beep at you if you're in danger. Its job is to be a silent witness. It just hangs out, clipped to your lab coat, and it passively records the total dose of ionizing radiation. We're talking beta, gamma, X-rays that you've been exposed to over, say, a week or maybe a month.
Okay, the best way to wrap your head around this is to just forget all the complex physics for a second. I want you to imagine a tiny little camera that's always on, right? It's clipped to your shirt. But here's the trick. Instead of taking pictures of light, its film only reacts to radiation. It's taking pictures of something we can't see.
So if it's basically a camera, how does it actually take this photograph of radiation? Let's get into the mechanics of what's happening inside that little plastic badge. It all happens in three really key steps. First, when that high-energy radiation passes through the badge, it slams into a special piece of photographic film that's tucked inside. Step 2. The energy from that radiation causes a tiny chemical reaction in these microscopic crystals on the film called silver halide, which, by the way, is the same stuff used in old-school photography. And finally, step 3, this reaction creates something called a latent image. Now, you can't see it yet, but it's an invisible record of the exposure, and the more radiation, the stronger that invisible image becomes. Okay, so an invisible image isn't very helpful, right? We have to be able to see it to measure it. And that brings us to the next critical step. We've got to develop the evidence. And this is where that camera analogy really hits home. Just like an old roll of film from a camera, the film from the badge gets sent off to a special lab. And there, it goes through a chemical development process that basically makes that invisible, latent image completely visible. And once it's developed, reading the results is so easy. It's brilliant. If you had a really low dose of radiation, your film is going to look light, maybe almost clear. But if you were exposed to a higher dose, well, that film is going to be much, much darker. It looks exactly like a photograph that was overexposed because it got way too much light. But this isn't just someone eyeballing it and saying, looks kind of dark. No, this is a precise science. In the lab, they use a special device called a densitometer that measures the exact amount of darkening on the film. They can then compare that measurement to other films that were exposed to known amounts of radiation. That's how they calculate the precise, exact dose someone received, making sure that safety standards are being met. The science here is pretty fascinating, but where this really matters is with the people who use it. So who are the folks who are relying on this little badge every single day to stay safe?
Well, the list is long, and it's full of incredibly important jobs. We're talking about radiologists and the X-ray techs at your local hospital. We're talking about nuclear power plant workers who are making sure we have electricity. There are industrial radiographers out there checking pipelines for safety, and of course, tons of scientific researchers who are pushing the boundaries of what we know. For all of these people, this little badge is a critical, non-negotiable piece of safety equipment. So let's bring it all home. Why does this simple little hunk of plastic and film really truly matter so much? I think this classic quote from the management guru Peter Drucker just says it all. What gets measured gets managed. It's so true. The only reason we can effectively manage the risks of radiation and keep people safe is because we have a reliable, simple, and effective way to measure it in the first place. And that, right there, is the real takeaway. This small, totally unassuming badge is basically the key that allows us to safely work with some of the most powerful technologies that humanity has ever created. I mean, from generating clean energy to diagnosing diseases, it's a silent guardian, quietly keeping watch over the unseen.
So I'll just leave you with this one final thought to chew on. If a technology that was dreamt up over a century ago can be used to reveal a powerful, invisible force like radiation, what other invisible things, what forces, what data Are we just on the verge of learning how to see, measure, and understand next?